Task 3 is all about constructive solid geometry. This is a native geometry included in OpenMC. It comprises of surfaces and volume regions. This is the simplest surface that one can define. So this is an OpenMC type sphere with a radius of 10 centimeters. So that would define the green sphere. And then to make a region, you just say, I am less than that sphere surface, and that defines the purple region. Then to convert this region into a cell, you just say, I'm looking for an OpenMC cell with this region is set to the region. Now don't forget to add a material to your cell, otherwise it will be full of a vacuum and neutrons won't interact there. This is a slightly more complicated one. We've got a surface, a sphere surface, and a bigger sphere surface with a radius of 20. So the region between the two spheres is defined as above surface 1, above the radius 10, and below surface 2. So this is an and below. Surface 2 gives the purple region. So the region is equal to the region between the spheres. Great. There's an important addition that you will need to make to your model. When you want to simulate, it's not quite enough just to set up your sphere and your surface and your regions. You also have to tell OpenMC where the outside of the model lays. So if this is the only cell in our model, we would have to add a boundary type equals vacuum to this cell, so that when the neutrons or photons cross this surface, they're terminated by the code and they're no longer tracked. OpenMC can support quite a lot of different surface types to make up your geometry. X, Y, and Z planes, as well as arbitrary planes, are useful. Cylinders with different orientations, spheres, and cones, and quadratic shapes. In this next example, we're going to see a few more. We're going to see a Z-plane, a Z-cylinder, and a sphere. But you can get the documentation for all of these types on the Reader Docs webpage. So this will tell you the arguments that you have to put in, and there they all are there. So there's a Z-cone. So in addition to making these volumes, you can perform Boolean operations on them. This is a Boolean operation for OR. So we've made a sphere, which you're familiar with, and now we're making a Z-cylinder and a Z-plane and another Z-plane. So these are at different intercept points. And then we're defining a region as below the sphere, which is this purple sphere, and we're also saying below the cylinder, below the upper Z-plane, and above the lower Z-plane. So that gives you this capped cylinder. And then we're defining the region equal to the sphere region or the region of the cylinder, which gives this combination shape. You can also do complements or knots. So this is very similar. We've defined our sphere and our cylinder. However, we're saying the region of the cell is equal to the region of the sphere and not the region of the cylinder. So the resulting shape is this. Finally, we can do interceptions where we say it's made of both. So we have a region which is a cylinder and a sphere. So everywhere these two overlap is our final resulting geometry. So in the tasks, there's 3 tasks in this part. You will make simple sphere geometry, and you'll learn how to colour the materials or the cells by your preferred colour. You'll also have the option of making more complicated geometry, which makes use of the Boolean operations. And last but not least, you'll have a go at making 3D visualizations of the geometry using ParaView. Let's have a look at that now. So I'm going to open the workshop using this Docker run command. and then I go to that URL, and I'm going to go to task 3, and I'm going to load up the last one, because I just want to show you how to do the last part. So I'm going to run the cells, and this is running open, and then at the end of the task I run this code block, and this gives me a download option, and I'm going to save the link as a VTI file in my downloads folder. And then in this terminal, which is not my Docker terminal, I'm going to run ParaView, and I'm going to open the VTI from the downloads folder. And that's going to open in ParaView. So, to use ParaView, I'm going to start by clicking Apply, and then I'm going to go to this, and I'm going to select ID, and I'm going to select Surface with Edges, and that gives me the 3D geometry. This eyeball here is useful for showing and hiding, and I'm going to take a slice. I'm going to apply the slice, and I'm going to hide the plane. And that reveals our 3D tokamak geometry. I'm also going to do a threshold operation, and I'm going to increase this by a small amount, and I'm going to click Apply, which gets rid of the blue. And there's our 3D geometry. Okay, hope you enjoyed task 3. Good luck.